Hello everyone, this is your civil girl. Welcome to the 5th lecture of reinforced cement concrete. In this video, I will be seeing about the material properties of steel. So let's get started. And before we start, I would really appreciate it if you could smash that like button, drop me a comment and share this free program with anyone who might need it. In the previous videos, we have seen the properties of concrete. We have seen the properties of both fresh concrete and hardened concrete. So in this video, let's see about steel. The reason why we use steel in construction is because it is good in tension. We know concrete is good in compression but weak in tension. That is the reason why we add steel. When steel is added to PCC, which is plain cement concrete, it becomes RCC. So there are many metals available. Why are we going for steel? The main reason is because steel has high yield strength, but the critical reason is because of the property called coefficient of thermal expansion. It is denoted by alpha. So we would have learned about the coefficient of thermal expansion in SOM. So coefficient of thermal expansion is the rate at which the material expands when it is exposed to the temperature, high temperatures. So if my thermal expansion is high, then it means that even for low temperatures, my expansion will be high. If my coefficient of thermal expansion is low, then it means that even for high temperatures, my expansion will be less. So let us look into the thermal expansion coefficient of concrete. It is 14.5. So if my concrete's expansion is 14.5, say this is my slab and this is my rebar. It can be of any metal, okay? Let us assume it will be of any metal. It has a coefficient of expansion of 14.5. So therefore my rebar or my reinforcement, it should have a coefficient of expansion almost equal to concrete or lesser than concrete. Imagine if the rebar which I am using has more thermal coefficient than concrete. Say it is like 20. Then it means that for a given temperature, this expands first. That is, my reinforcement expands first before my concrete. Imagine for a temperature, if my reinforcement expands first before my concrete, then this expansion will deteriorate my concrete, and as a result, the whole structure may fail. Because of this, we are going for a thermal expansion property of a material which is similar to that of concrete. So that is why we use steel, because steel's coefficient of thermal expansion is 12, which is near to concrete and also lesser than concrete. And that is the reason why we don't go for other metals like aluminium, because its thermal expansion is higher. It is almost 22.5. Next, let us look into the types of steel. As per IS 456, there are 4 different types of steel. First is mild steel bars and medium tensile bars. So the mild steel bars are which yield strength of 250 MPa. It is also denoted as Fe 250 bars, and it is not used much in the construction, not in India, but however in foreign countries, mild steel bars may be used for lateral ties alone. Next is HYSD bars. This is called as high yield strength deformed bars. So HYSD bars, they have nearly 50% more strength, that is more yield strength than the mild steel bars. Also, these HYSD bars, they are having a carbon content more than that of mild steel bars. That is the reason why they can be yielded so much, and that is the reason why they have high yield strength. And mostly these bars are the bars available in the market, that is Fe 415, Fe 500, 500D, etc. So these bars, they are of 2 types. First one is hot rolled bars, second one is cold worked, also called as cold twisted. So these mild steel bars are plain bars. They don't have any markings or indentations in it. Whereas HYSD bars, they have twisting indentations in the HYSD bars. So we would have seen these twistings. This will increase the bonding between the cement paste and the steel, and thereby increasing the strength of the concrete. Next is hard drawn steel wire fabric. These are not bars or rods. These are meshes, something like this, and these are used mostly in shells, pavers, etc. Next is structural steel conforming to grade A of IS 2062. So these steels are nothing but the angle sections, I sections, etc. We know they are most commonly used in steel structures, but they can be also used in reinforced cement concretes, such as in heavy structures such as piles or some other heavy foundations. So these are all the types of steels available as per IS 456. Now let us look into the advantages of steel. The advantages are, for the same load, say this is my member and it has to take this much load, say 50 kilonewton. If my concrete alone structure, the only concrete structure takes this much area, then if I am introducing bars, that is rebars, then the section can be reduced considerably. Next, less cracks because of all the tensile stresses will be taken by the steel. Next, obviously high strength of concrete. Disadvantages are, it may be subjected to rusting if it is exposed to the environment, and also when it is subjected to high temperature it loses its strength. And also another property to note here is the modulus of elasticity of any steel, be it mild steel or HYSD bar or any steel, it is 2 into 10 power 5 Newton per millimeter square. Now let us look into the stress strain curve of steel. I have three different types of steel here: Fe250, Fe415 and Fe500. These two are the HYSD bars and this is my mild steel bar. So let us look into the stress strain curve. So firstly let us look into Fe250. So we can see that at the starting my stress and strain are linear up to this point. Let me highlight Fe250 alone. We can see that till this point my stress is proportional to strain. So this is my proportionality limit. Next, I have my upper yield point and lower yield point. I have drawn this bigger so that I can explain it. In reality, this curve will be very small like this. So this is my upper yield point and this is my lower yield point, and this part is my plastic part, and this is my ultimate stress corresponding to here. This is my ultimate stress, and till this part this is my strain hardening. And after this necking will happen, and here failure. So this is the stress strain curve of mild steel bar. It is very prominent and it has so many properties associated with it, and because of that we will be able to find the yield strength of mild steel bar very easily. With our upper yield point and lower yield point, we will be able to achieve our yield strength, which is 250 MPa. But for Fe415 and Fe500, we will not be able to find it directly. We will be using this Fe250 as an subdata to find the yield strength of the HYSD bars. So let us look into the yield strength of HYSD bars. So we know that HYSD bars, they have 50% high strength, yield strength than that of Fe250. That is the reason why they are at higher stresses. They are able to take higher stresses here, and that is why their curves are higher than that of Fe250. Now let us look into Fe415's curve. Let me highlight that alone. So this is my Fe450. It is linear till this point, but I don't have any upper yield point or lower yield point here, so I may not be able to find what is my yield strength here. So what I'm going to do is, I'm going to come back again to my mild steel bar, and in this mild steel bar I'm going to see where my lower yield point takes place. It takes place at a strain of 0.2%, which means at a strain of 0.002 my lower yield point is occurring. So I am going to take this point here. I am going to draw my mild steel stress strain curve in the same curve, and I am going to find the lower yield point strain. So now that I have found this point, I am going to take the slope. The slope for the elastic part of the steel is same for both Fe415 and also Fe250. So I am going to take this slope. So I'll have my stress here, strain here, and my elastic modulus here. From this I know the slope. So what I'm going to do is, from this 0.2% strain, I'm going to draw a line with the same slope of that of this E. So when I draw such a line, so this is my line and it has the same slope as that of E. So this is my E. So now the point which coincides with this line, the corresponding stress which coincides with this point will give me Fe415's yield strength, and the corresponding stress which coincides with that of this point will give me the yield strength of Fe500. So this is how we'll find the yield stress of Fe415 and Fe500, and there aren't many questions asked in this topic till date. We can expect questions from this topic in future. So thank you so much for watching, guys, and next video will be about the stress strain curve of cement paste, aggregates and concrete. Stay tuned. I'll see you in the next video. Bye.